World Bank of cash crop life expectancy globally. So we are looking at countries now, not states. So we're looking at, and it's an historical data from year 2000 to year 2010. That's the data we're going to be using tonight. And then we're also going to be looking at the total world population. So what we're going to do tonight is we're trying to establish a connection between the population of these countries and the life expectancy of cash crops in this country at the same time. That's what we're trying to look at tonight. So at first, there might be a lot of things you might see that you might not really understand because I'm going straight into Python, but I'll try and explain as much as I can. I can't explain Python in 45 minutes. It's not possible. Or as we go ahead with the with the training, I'll just try and explain the things I'm doing. You might not really mind the lines of codes and all that, but just try and understand the concept behind it in the real sense. So I'm going to be using these tasks tonight, and then we'll later look into the job search after that. So I'm just going to close this now, and then we go into this. Just a sec. So for Python generally, we make use of different format, but for me tonight, I'll be making use of Jupyter Notebook, which is just any note. There are different notebooks that you can use. You can use Spider, you can even use normal notebook on your laptops and all that. So, but I love Jupyter Notebook because it gives me this interface to give explanations to my data and all that from time to time. So I'm just gonna launch this one, and then we can start up something. Um, just a sec, and then we see what we can do tonight. So bring this up here. Just give me a sec, please. I will be there right now. Then, right. So I'm just gonna open this is a new Jupyter notebook I've opened here, and then probably I just put it side by side with the instructions we are supposed to work with. So here are the instructions we're supposed to work with here, and then we see how far we can go. All right. So while I was working on the slides, I made an explanation to you guys about how we, come in. I don't want this in here. Slides. All right. Can we all see this very well now? I don't know. Can we all see that? Can we all see both slides, both sides? You can just respond in the chat if we can see it properly. Okay. All right. So um, remember the methodology we went through. We said we look at data requirements, gathering and collation. We look at data import. We look at data gathering. We look at data exploration. So what I'm going to do now is I'm going to combine the data collation with the data import first on the Jupyter Notebook. So basically, our first task says this task requires you to use the data set world life expectancy. So I have this data set already, and then this data set is available on the module, is on my module under the assessment folder. So I have those folder all here already. So you might not have access to it, but when you're having a longer training with Farm Global Technologies, these are the things we give you access to because we need you to work on real life projects. So That's why we bring this kind of things out for you so that you can work on real life projects when it comes um, to data analytics or graphics design and all that. So we give you folders where you have things that you need, documents that you need to work on. So it says use GeoPandas or similar visualization tools to plot a set of corporate maps representing the world life expectancy of the year 2000 to 2010 respectively. So um, I just go straight to that. So just to introduce to the interface, this is a Python interface, like I said, and you have options of using a code. The code is things you want to run, or the analytics or all that is where you put in codes. Markdown are just explanations that you want to put. Raw MB converters are just fonts, designs, graphics, and all that you want to put. Headings are things you want to put as headings, just like this is the heading to this part and so on and so forth. That's how that works. So what I'm gonna do now is I'm gonna start with a markdown so we know what we're doing. So for the markdown, before we go into our first calculate our data, we need to also import our data in before we can now start into what I'll just do is what I'm doing here is I'm looking at everything I'm going to need for the purpose of this analysis is what I'm looking at here. So I just want to import the libraries, or just to save time, let me just use the code directly, and then whatever whatever is not useful in the code, I just put an hash behind it. So I want to import the libraries first here, and the libraries I need usually I need the pandas library. So you need to import all the libraries that you need. So pandas is just plugin in Python that allows you to do mathematical calculations. You want to calculate mean, median, mode, and all that. So make use of pandas for that. I'll also import, let's copy this import just so that I won't keep typing it again. So we can also import NumPy. So the NumPy basically is for arrays. So we are going to be dealing with columns, with rows and columns. So that's why we need NumPy for that. So basically, you just need to import everything you need um, for the purpose of doing the analysis. So I would also import GeoPandas. So usually you don't need GeoPandas, but because of our time, and I said I want to bring in GIS into the data analysis environment, is why we have to use GeoPandas now so that you can be able to draw maps and all that as well. So because geospatial analysis is a very um, big aspect of agriculture nowadays. So I'll just use that as GDP. No, I think it was GPD. So what else? What else? We might decide to plot some graphs. So let's use Plotty Express for that. So like I said, there are lots of, this is what I'm using. It's Python. There are lots of different things you can use. Some people will use Seaborn instead for this directly. Some people use Matplots, different things. So let me just use this one. Let me use Matplot as well. And then Matplots, YB, YPlots, YPlot. Yeah, that's it. All right, so with this now, we can do most of the analysis with Plotted Express, with Matplots, and then let's import Seaborn as well, just in case we need that. So sometimes you think you don't need some things, but when you look at the task at the end of the day, you discover, oh, I need some things. You have to go back up and then start doing some new set of importing. So I'm just going to run this and see what comes up. So okay, there's an issue. There's the issue. Plotty, no module name plotty. What's the next? Imports plotty express as px. Um, so usually we get errors anyways, but let me just hash this out and then run it again, then see what comes up. All right, so the issue is just with plotty express then. So I should have a look at that and see why I'm having an error there. So I would have a look at that later on and see what's wrong. Uh, oh, it should be plotly. I think it's the spelling. Sorry, let me just run. Okay, so it's just the spelling. Like I said, usually there's always funny errors that we get from from Python most times. So now I brought in all the libraries I need, and now I need to import my data in. So what we are working on in our first task says we should work on the live expectancy data. So I'm going to open this data in Excel now first. So we have a look at what kind of data we're actually working on. So we've got a live expectancy data here in Excel. So this is where data extension comes in. So now looking at this data, we've got country name, we've got country codes, we've got indicator name, which is life expectancy of cash crops yearly, indicator codes, and we've got from year 1960 till, this is an historic data till year 2009. So this is what we talk about when we talk about historic data, continuous data from 10 years, 15 years, that you can actually look at the trend and make conclusion. So this is life expectancy of cash crops for these countries for over this year. And then we're looking at the second data I'll be looking at today. It's a population data, also from World Bank. We've got the country code, country name, country code indicator, which says total population of this set of countries from that same 1960 till year 2020. So you see, we've got loads of data to work with. This is a lot of this is an example of a big data. Got loads of data. Loads, like you can't start doing plus or minus manually. You need a system that can just work for you to work out with it. So if we observe, we can see we've got the title here. We've got the first four columns have issues because there's nothing there. So if we import it in, let's see what we can do now. So I'll go back to the environment we're coming from now, so we can start working on that. So I've got the data here. I've got input data here at this side here. So I'm going to read them in now. So we have a look at that. I'm going to read, let me just say import data. So import data, um, I'm going to use pandas. So that's like I said, we brought in pandas here for a purpose. So I'm going to be using these pandas here that we've imported here to import this data in. So let's just name it live expectancy. Say live expectancy or live exp is equals to, so PD is what we brought it in as. We use PD dot read data. So the file we are bringing in is a CSV file. So majorly Excel can come in form of comma delimited, that's CSV. It can come in form of the usual Excel 97 or 2013, which is XLSX. So, but this file we are bringing in is a CSV file. I can see here, can see CSV here. So we bring in a CSV, and then we have to put in the name of data we are bringing in. So we are bringing in life expectancy data now. So I just copied the name here of this data we are bringing in. Then I paste it in here. So that's the data we are bringing in. Remember when we had a look at it, remember that the first four columns were we're having issues. So we have to skip the first column, and it definitely has an header. So an header, we put an header, we skip the first skip column, and then we have a look at the lines that doesn't have nothing out of the first four columns. We take that out as well. So I'm going to put an header there now, which makes it header 0, and then I'll skip rows. Um, so we are skipping the first four rows, so that's equals to 4, and then we give the error value as well. Uh, Error bar lines um, false. All right, so let's run that now. Okay, there's an issue. There's always an issue anyway. So let's just have a quick look at what the problem is. We have skip rows, we have error lines. So basically, the only issue I can see here now is the fact that I didn't close my bracket. So I'm supposed to close this bracket here and then I run it. So usually there are literally two errors like that. So now this is working. So I'm just going to have a look at, we want to have a look at what I have imported in now. So to have a look at that, I can just write live expect ef exp, and then I run that. So it's not defined. What's different? Live exp. Oh, okay. So like I said, I used a capital letter for that. I used a small letter for this. So yeah, this is it now. So if you remember the Excel sheet we had a look at, remember I used 0 as my header, which is the first line, which is what I have here: country name, country code, indicator, indicator code, and then you've got the years 1960, 1965, and so on till the end. You've got all that there. So basically, we have all the data imported now. I'm having a look at it in the Python environment as well. So the last column is 2020, which had nothing in it. So we have been able to import this um, into our environment. However, if you remember on your right hand side, we spoke about data wrangling, where we do data cleaning, data transformation, where we do some mapping and so on and so forth. So obviously, this data would definitely have some, null values, outliers, and so on and so forth. So we have some missing values even at the middle as well. So we've got 266 rows and we've got 65 columns. Now, what we need to do now is we need to sort out the rows um, that might have, issues or might not be complete for a reason or the other. We need to sort them out first. So um what's the time now? Let me have to look. Right, our time is fast spent. So um I'll just work with let's just work with the task 1 here, and then we'll leave other tasks because other tasks will take a lot of time as well. So um I'll just work with the first task here to just do visualizations from you, and then we'll have a look at it one after the other. So um for the first task, what we need is we need 2000, 2010, which means 1996, 1960, 1961, all these are not useful for this. So we need to take out the useful columns that we need so that we won't make our data look very rough and all that. So I'll just say pick out useful data, pick out useful data. Then we use life expectancy. Life exp equals to, so from the main, our main life expectancy here is what we're going to use. So we are bringing out some data from our main life expectancy, which we've imported originally, and then we're going to use, there's something we call ilocate on on pandas. So it's more of like you telling the computer to, or you telling Python to actually locate a particular thing specifically out of a big data. So we are working on a big data now. So they can't be inspecting or looking through it one after the other. So we've got a way of doing it on Python where we use the ilocate to inspect the whole data and then bring out what is useful from it for the purpose of our analysis. So we are going to be using life expectancy again. I'm just going to use the same life expectancy dot loc. That's where we have used the ilocate now. So the loc is the ilocate. Now you must note that for every bracket opened in Python must be closed. If you don't close a bracket in Python, you it will just always give you error. So like we did an example the other time when I didn't close the bracket and then um I just nothing showed up for me. It was just writing an error. So what we're after now is we're after the country name, we're after the country code column, and we're after year 2000 till year 2010. So which means every other data apart from this year 2000, 2010 is not useful for this analysis. So with that, we go to, I take out country code and I think I'll just take out the country code and I'll take out the country code and country name and country code. Sorry, I mean. So I'll just put this in there and then I'll I'm just in a bit of a rush is why I'm using a bit of shortcuts. So apart from that, we are bringing in also the life expectancy. So we're going to bring in the list back in here and then we're bringing um, life expectancy again. Oh no, that's not it. We're bringing life expectancy again here. Bring in this one. So I'm just doing the copy and paste so that I don't make spelling mistakes. If we get that, you could type it if you want, but if you use the copy and paste, at least you know there won't be spelling mistakes with that. And then um, you use the ilocate again, and then you open a new bracket again, and then you put in the years you wanna select. So for me, I'm selecting from year 2000 to year 2010, I believe. So I just select the year 2000 to year 2010, and then close my brackets. I close this second bracket which I've opened here, and I close the main brackets which we opened at the front here, and then I run my data again. So with this now, what I need to do now is I need um, to view this data just to see what we've got. So I'll view life expectancy now, and then I run it again, and then we see what we've got. So can you see? We've got now country name, country code. We've got year 2000 till year 2010. And then every other data that was originally in the first one was taken out now. So so we can see the difference. I just do this Take this out, run this. So you see, this is year 1960 to year 2020, and then we bring this out of that, and we have year 2000 till year 2010. So now from this one now we got 266 rows and 13 columns now, which means we've taken out about 50 something columns already that are not useful for the purpose of analysis. However, we are here to clean the data, so we need to clean the data first. So the best way to clean is just to remove null values. So what we say null values are empty columns, empty rows, and all those things. You take it out of your data, and then it's going to show you what is left for you. So I'm just going to remove null values. So we do remove null values. And then with that, you've got, we're just going to say, let's just call that expectancy, uh, UES. Let's call that expectancy. Expectancy is equals to, so the name we named the first one is life expectancy. So we're going to use this one now. And then we bring it back here. See, expectancy is equals to life expectancy dot drop NA. There are different ways of doing it. Some people don't use drop NA. Some people use a different, line of code. There are lots of different codes in Python that you can use for your analysis. So it doesn't have to be the same thing. And then you print out EXP. So when you run this now, you've got how many rows now? You've got 247 rows. So now the rows have reduced from 266 to 247, which means there were some missing rows or empty rows, which the data has taken out now. And then what is left of you is just this. So for printing, for example, some people use just exp like I've used now. Some people can say, they can say print. Some people use print exe, and then they put this in front and they run. Is that exe dot edge? Yeah, so some people can use this. So this is shorter. This one is just saying print the first 5 rows. That's the meaning of this. So it's also showing you, I said, this is data inspection. You just have to look at the whole data. What have I got? So now we are going to be working with a data now that has just 247 um, rows in it, in the real sense of it now. So to do this now, let's have a look at the data available. So remember when I said this, I mentioned something to you guys when we are talking about data import. I said data import lets you upload data from external sources and combine it with data you collected via analytics. Now, there's some data available on GeoPandas. This is where I bring in GIS into it. There's some data available on GeoPandas. So GeoPandas has the world data already that has what we call longitude and latitude. I don't know if everybody have heard that from time to time, but longitude and latitude is a way of locating specific points in the Earth's surface. So we're going to use that now, and we're going to read in data that are in GeoPandas. So I'm just going to copy and paste that to free the time of that. So um, usually, you're supposed to check for available data in GeoPandas first before you do this. Usually, but I'm just going straight to the point. I didn't bother checking available data because I already know what data is available, so I just put it in there. But or let me just do that for the sake of people in here, so I won't just jump steps for you. So what I'll do is let me check available data first. There are ways you check available data on any frame you are working on. So we say check available data, and then to check available data, remember GeoPandas was brought in as GDP here, GPD here. So you come back here because you want to check available data on GeoPandas. You say GB, we brought it as GPD dot data sets dot available. So that's how you check for available data. So if you run this now, it's going to tell you that this data, natural earth cities, is available, and natural earth low risk is available. These are the two data available. So you can open both data to see what is there, but for the purpose of this, what we need is this natural earth low risk is what we need for our task one. So I won't bother checking both because of our time. I'll just go ahead and then pick the one I want to use, which is natural earth lowest, and then I run the data and get that data out, which is this. So we've got population, we've got continents, we've got names, we've got all this here. We've got IUS. This is country code, but it's not written as country code there, which means we need to change this name to country code for the purpose of merging. And then the most important thing we need here is the geometry, which is the longitude and latitude. So we are going to bring in, we are going to change this name first, this country code first, so that we can merge it using country code to this data. Remember, we have country code here, so we need to make them the same name, and then we bring them in together. So first of all, we change the name, so we rename it first of all. So I'm just going to copy and paste that as well, because I have always been working with data in GeoPanda, so I've got those ones working already, so I don't need to rewrite them. And then we just like we did for these, where we brought out useful columns. So in this one now, we don't need population estimate, we don't need continent, we don't need name. Well, we need name, but we don't really need to put name. But the most important thing for us here is the longitude and latitude and the country code. So I'm going to bring out the longitude and latitude just like I did for that, removing just using iLocate to pick out the important things I need. I do the same here as well, and then I run this as well. So can you see I brought out country code and I brought out geometry, and it makes it 177 rows, which means I have longitude and latitude for 177 countries. Meanwhile, my data at the moment has 204, no, 247, because we cleaned this data already. So I'm just gonna take this out, and then I put in expectancy back so we can know the amount of column we are looking at. So we have 247 rows now, and then I have 177 longitude and latitude. So this is still under data cleaning, which means if I combine this data, there will be some rows that would not have geographic location, which means those rows I need to take them out again. So I'm going to take out, to merge this, I'm going to take out the rows that do not have rows that do not have um, I'm going to take out rows that do not have your longitude and latitude, which is the geometry. And to do that is just by combining both data together. However, I'm going to be using this geometry data as my base. So what do I call base? Base is a reference point of your data. So if I use this as my base, it means 177 is the base of 247, which means there's only 177 data that I need from the old data that is accurate. So to do that now is where I bring in merge. So I'm going to merge data together now. Um, so I'm merging. What I want to merge now is I'm going to merge this expectancy data into world data. So I'm merging into world geo data. This data I'm looking at, this last data where I've brought out just geometry from it. So I call it world geo. Yes. So um, the clean life expectancy will be world geo. Like I said, you make it the base. So I'm saying merge life expectancy data into world geo. Is what I'm doing now. So using what? Using country code. So that's the meaning of what I've written here. Merge life expectancy data into world geographic data using country code, because this one consists of country code and this one also consists of country code. So you have to use a unanimous column to actually combine two data together. That's how it works. If there is no unanimous column in your data, you can't combine those data. So that's why we had to change the name up here. We had to change the name iOS here, iOS A3, which was what was available. We had to change it to country. You can see word rename. We renamed it here so that the country code can be a unanimous column name for both data. And then with that, we can I'll just give the shorter name. So I won't have to be writing too much. Expectancy one, let's just say clean expectancy. So after this one, we should be clean by now. So just use clean expectancy, and then let's run that. So can you see what we have now? We have country code on one column. We got geometry, and then we've got country name. We've got year 2000 till year 2010, which is what we need for this first one. And if you have a look at it well, you see it is 177 rows now. So which means other rows that didn't have geometry has been taken out of it for us. So um because of our time, I won't do any other cleaning. There's still more cleaning you used to do. You need to do outlier cleanings and all that. But for now, this data we've got is kind of good enough because of our time. And then we just see how it works because it's 6 o'clock already. We spent an hour basically. So I'm just gonna draw I'm gonna draw a map of the life expectancy, and then we see how it. So let me plot. So it says plot a chloroplet map presenting the world life expectancy for year 2000 to 2010 respectively. So we have geometry, we have 2000 to 2010 over year, and then we just want to plot it on a map basically. So I'm going to call this plots chloroplet. So um So remember we brought in some tools in the past. We brought in PLT, Matplot, we brought in Plotly Express and all that. So let's use the Matplot. So Plotly Express can be used to plot map. I can show you that later on. But let me just use the Matplot now to plot for the purpose of this. So we want to plot life expectancy from year 2000, right? Uh, to 2000 and what? Oh, for the years. So the question says for the years. So which means we are plotting for year 2000 separately. We are plotting for year 2010 separately. So it's not from 2002. It is for the year 2000 and 2010. So I'll do 2000 first, and then we see if we can do 2010 as well. So um, I'm just gonna write this. So basically, we need to give it a reference point. Where are we bringing, uh, which axis are we bringing in? So usually, the to use longitude and latitude, we need to bring in what we call grid. It's called grid one. We have different. We have grid one, grid two, grid three. So grid one is the one that works with um, like maps and all these charts and all that. Grid two works more of like like bar charts, pie charts, and all that. I think grid three works with line graphs and so on and so forth. So what we need to use for a map is grid one. So, and remember we are using GeoPandas from the start, which means we are under GeoPandas framework now, not just pandas. So um, pandas can't do maps for you. So, like I said, we don't need to do maps basically, but because I'm not going to be showing GIS for tonight anymore, so I'm combining both together into Python to save our time, and then we are going to be bringing grid one into this. Like I said, we are using a map, so that's grid one, and then I import my axis. So import make axis locatable, make axis locatable. Um, make axis. Then I put my figure to let them know what my axis. So my axis I'm using is AX. So which means anything I'll be plotting will be AX. So I'm just gonna plot with AX and then we see how that goes on. So anyways, it's two ways. I can plot without overlaying, but it makes more sense to overlay. This is the reason. If I plot a map of all this for you and you look at it, you can't really compare. But if I overlay the map of the world, the normal map of the world, and then I plot my life expectancy on top of it, it's going to make more sense to us, because you can see what color is high, what color is low, what color is, you can see it differently on the map, rather than just seeing just some colors around and not knowing which area, which region, which shape it belongs to, and so on. So I'll do an overlay now, just to make it so remember we are using matplot, so I bring in plt here, and then I use a subplot. So um subplot is just to give you the size you want. So I use size 1 by 1, and then I bring in my world geodata. That's my world geographic data. So if I put my world geodata here, world geodata, and I plot it, plot, and I put it on my axis. Remember, I already put an axis there. So I said ax equal to axis. So I put ax equals to ax. The axis I want it on is ax equals to ax. So I want it on axis ax, and then let me run that first. So have you seen what I've got? This is the map of the world now, but you can't see anything on it yet, in it. You can just see this is just the map of the world. There's nothing on the map of the world yet. So now I want to plot year 2000. So let me hash this out so you can see the difference. So I'll plot year 2000 only now. So the reason why I have to put my world geodata first is because whatever you want to be under, you arrange it according to how you want it to be. So first I want my world data before I want my life expectancy data. So my world data comes under, my life expectancy data comes on top. So I'm going to bring in my life expectancy data now, and then we quickly rush into a bit of interpretation based on what you see, and then we work on that. We leave the rest for another time. So we've got clean expectancy here, which is the data I want to plot. So I bring clean expectancy back down here, and then I plot it the same way, just the way we did that. So I use dot plot. Now it's not just plotting. I have to specify the column I want. Remember, we are doing just 2000, which means I'm looking at column 2000. So I have to specify that column name here by saying column. What column do I want to use? So I say column is equals to. So whenever we are doing Python, we should always not forget our quotation marks. It's very important that we put quotation marks in whatever we're doing. If not, it's not going to read words, because if we don't put quotation marks, it's going to read it as numbers. But because it's a column name, we have to make it text. The quotation mark makes it a text. And then where do I want to plot this map? I want to plot it on ax. So I put it on ax equals ax is where I want to plot it. And then I want it to have a legend. So I put a legend. Legend equals true. So the T has to be capital, I think. So with that, I can take this out of here, and then we see what we've got. So we've got um clean expectancy data dot plot, where my column is equal to year 2000. I want to plot it on ax as well, and my legend is equals to true. I plot this now. You see what I've got now? So with this, you can actually look at this map and say it means for countries in here, the life expectancy for countries that are below 40 is showing as purple. Life expectancy for countries around 60 is showing as green. Life expectancy for countries that is above 75 is showing as yellow for the crops that are there, for their cash crops. So now let me put it on each other so you see the difference now. If I put it on each other now, you have these. So now I have overlaid your life expectancy data on the world data, which means you can see other countries that are not included. So all the countries by here, the ocean countries, polar region countries, are not included, which means there are no cash crops that are actually growing there, probably because they are too cold. We can now know that there's a reason why um there are no cash crop growth in those regions. So I know we all know it's about the cold. Polar regions are very cold, so we really can't get crops to grow just like that in polar regions, except for crops like cactus that are very, very stubborn. and they can still grow in areas that doesn't have water, or in areas that are extremely cold as well. So you have some cactus plants there as well. So uh, this is just an example of the map. Now, from this, what can we look at? What can we see, or what can we assume is happening? So basically, your map should have, you should have your legend. You should have, you should explain what each side. Okay, let me just give a bit of, let me see if I can find something to put in that, so we can have a bit of label to have to understand what the data is a bit. So I'm going to put a legend there for you. I'm going to put names and all that for you look. So we have this now. So we've got latitude, we've got longitude. So this is location. So with this, you can read exact locations of the areas. I'll have put a label, but label will make it scattered. However, Python won't give you design, or design graphics and all. Python is really based on analysis. However, a proper GS environment like the ArcGIS, which I was supposed to use tonight, would give you that. If I import all this into ArcGIS, I can edit, I can design, manipulate the way I want. But Python is very good for automation because, for example, 5 years later, I needed some data to run about maybe life expectancy of rather than cash crop, maybe for fruit crop or for orange. I have my data. I just go back here. I change this data to the data I'm trying to get the life expectancy. I come to my cell here. I run all. So it's very good for automation. I don't always have to repeat the same thing every time when I'm on Python. I'll just go in there and work on automation and then I get it done. So that's how it works basically in the Python environment. So it's a very, very, very um, useful tool in agriculture. I will have gone ahead to give you more of these because, okay, do you want us to go ahead and do for do you want us to go ahead and do for 2010 as well?
No,
Sorry. All right, so let's put a
right.
stop
So
here then, and then
let's do this up here then, and then
we we just
we
go into
we just going to
job searches quickly. So I'll just go into
job
this quickly.
statistics. So I just
So
going to
I
this
would just want
quickly.
to let you know what kind of jobs you can get as an agri data analyst. So I'll just I'll close this now and then we go one after the other into this. So all right, so we've got these roles here now, and I'm just gonna do that briefly. So this is an example of the jobs you can get. So this is a job site. Just looked at jobs on Google. You can be a farm business analyst. You can be a senior associate agribusiness partner. You can be a business consultant. You can be a capital market and so on. There are lots of jobs there for agri sectors. Um, so it just depends on where your interest is built. So if you've got interest in let's have a look at their salary ranges as well. Let's see what we can get on salary range. So salaries, this is Glassdoor. So using Glassdoor for these at the moment just to see what's the range of salary people earn. Okay, this is showing in pounds. Um, okay, I guess it's because of my location is why this is showing in pounds, but even in pounds, this is a whole lot of good money in pounds. So let's let me streamline and see what we've got, see if we can get anything about jobs in Nigeria rather than in the UK. Just see what I can type in here and then. All right, so we've got senior analyst role in Lagos, Nigeria. As you can see, this is Senior analyst role in Lagos Sahel consultant is an agri-tech company. Agribusiness analyst is another one. Those are roles in Abuja. Agribusiness investment analyst, senior role business development, market analytics. So these are analytical jobs. These are jobs for analysts, for agribusiness analysts, basically. So it's not just about you learning the skills, it's about how useful it is in the present economy we are facing. So it's not just about just learning it, knowing how to do it or all that. No, it's about knowing if it is viable. So this is Salary Explorer. It says average monthly salary is about 886,000 naira for people who are agri consultants. You are an agri analyst and all that. So you've got a minimum salary of this and a maximum salary of this. So they can't pay you below 243,000 is what it's trying to tell you. Medium salary, the percentile and so on. Let me search for on that pay scale. Let me see what pay scale has got. So for pay scale, let's see, they have got different ones. So you can be in a business consultant, this is an average, anyways. Business development associate, an average. Business development manager, an average of the amount of money that a salary that you can earn with those jobs. So which means I'm just showing you just know that these jobs are available there, they're out there. They're out there. They pay good money for analysts basically, because this is a way of integrating IT into agriculture and is a fast moving uh you know scale in this period that we are in Nigeria. Everybody don't want to waste money anymore. We all want something that can tell us this is how much you make if you do this. So I don't have to waste my money to do trial and error. That's why we need to start moving into data-driven agriculture, an agriculture that moved with data. So I've got few references here for you to have a look at later if you wish to, not compulsorily. And then I think that should be the end um, of my slides now. So I'm just gonna give rooms for questions and all that now, and then we see how far we can go. Thank you. Over to you, Mary.
Thank you so much, sir, for the session. Can you hear me?
Yes, I can hear you. Sorry.
Yes,
Yeah, you're welcome.
you're welcome.
I
Okay.
can hear you.
I can hear you.
Since Miss Mary is having a network issue, if anyone has a question, you can kindly raise your hand and will be asked to speak, or you can always drop it into the chat box.
Hello?
Hi.
Hello?
I
Hear you, Bashir.
yes.
Job, well done. Thank you. We'll be glad to have such a kind of session in the near future, sir. Thank you.
You're welcome. Have you got any question?
Do anyone have a question? In the absence of no question, I think we are done with the section, and I'm still waiting for Miss Mary to speak up. I don't know why it's not saying something. Maybe a network. Once again, I want to appreciate our trainer, Mr. Temitope Wilson, for this wonderful session. It has been an enlightening and educative, likewise an interactive session. We really appreciate you, sir. Thank you so much for your time, sir.
Yeah, you're welcome. You're welcome.
Miss Stella, do you have anything to say? Hello, Miss Stella, are you with us?